Hello class, this is another video that I've made. This is the third video I've made in conjunction with what is needed for the project. And this portion here is called variation. Now the first two videos I made was basically for one type, which was that square root process that you would need for one problem on the project. And now you would need this for the project as well, which is called variation. And particularly, what you need here is direct variation. And the reason why I'm cutting to the chase here is because time is of the essence for the project. It says here, if y equals kx for some constant k, then we say that y varies directly as x, or that is y is proportional to x. The constant k is called the variation constant or constant of proportionality. If y equals k over x for some constant k, then we say that y varies inversely as x, or that y is inversely proportional to x. The constant k is called the variation constant or constant of proportionality. In most cases, solving a variation problem will require two steps. Use given information to find the variation constant and write the variation equation. Number two, substitute into your variation equation to solve for the unknown. Okay, number one. If y varies directly as x and y is 18 when x is 3, find y when x is 5. So we know the direct variation is y equals k times x. Okay, so now we know it's y equals k times x. So they give us y, which is 18. We don't know what k is, because I'm having problems drawing k's here. We don't know what k is, but we do know x is 3. So basically we're doing all this to solve for k. So we divide each side by 3, and 6 is equal to k. So your new formula would be y equals 6x, because now k is a constant. So since k is equal to 6, 6 will be constant. Now, they give us a second portion. Find y when x is 5. So we would take y is equal to 6 times 5. So we have y is equal to 30. Both of these are your answers. The formula and also what they ask you here. Find y when x is 5. Now we go here. If d varies inversely as t plus 3 and d is 5 when t is 4, and find t when d is 9. Okay, so now we have d varies inversely, so that would be k over t plus 3. Because whatever it varies inversely as, the k goes above that. So now they tell us d is 5, and they tell us t is 4. So now we're going to solve for k. So we have 5 is equal to k over 7. Now we have to get rid of that 7 from the denominator. So we'll multiply everything by 7. 7 times 5 is 35. These 7s will simplify out and leave you k. So now you add d. D is equal to, it'll give you 35 over t plus 3. Because 35 represents k now, and k is a constant. So now they tell us find t when d is 9. So we'll make d 9 is equal to 35 over t plus 3. Now we have to get rid of this t plus 3 in our denominator. So we'll multiply each side by t plus 3. I'll put that in parentheses. So t plus 3 times 9, we're not going to distribute this. We're going to add 9 times the parenthesis of t plus 3 is equal to, these t plus 3's will simplify out. That will equal 35. Now we will divide each side by 9. And we add t plus 3 is equal to 35 over 9. Now, remember, we're solving for t. So what we're going to do next is this here. We're going to subtract 3 on both sides. So we have t is equal to 35 over 9 minus. Now, instead of minus and 3, we could change this 3 to a fraction that has a denominator of 9. Because we know 27 divided by 9 is 3. So this will end up being 8/9. So t is equal to 8 over 9. So this is one answer, and this is the equation that you use to get that answer. Now we scroll down here where we have the application problems. It says here, the current flowing in an electrical circuit varies inversely, so we know we're going to use the inverse formula, as the resistance of that circuit. If the circuit is 25 amps when the resistance is 4 ohms, find the current when the resistance is 5 ohms. A car is traveling at speed s miles per hour. So first of all, we have here where it says it varies inversely. Okay, so since it varies inversely, so we will have C is equal to K over R. Okay, because we're doing the resistance. It varies inversely with the resistance. So they tell us that we have 25 amps, which is the current, is equal to, we don't know what K is, but the resistance is 4. So we'll multiply each side by 4. And then that will give us 100 is equal to K. So now our new formula would be C is equal to 100 over R, because that 100 replaces K. Now they tell us the resistance is 5. So we have C is equal to 100 divided by 5, and C is equal to 20 amps. So we know this is our final answer. This is our formula. Now, we come here to number 4. It says a car is traveling at speed s miles per hour. The braking distance d varies directly as the square of the speed. If a car traveling at 60 miles per hour has a braking distance of 226.8 feet, find the braking distance for a car traveling at 70 miles per hour. So we need to write this out. This would be d, which stands for distance. So we have d is equal to, and it says it varies directly as the square of the speed. So it'll be k. Okay, and it says the square of the speed, so it'd be k times s squared. So now they tell us if a car is traveling 60 miles per hour, so they tell us the speed, and they also gives us the distance of 226.8, and that equals to k times 60 squared. So we had 226.8 is equal to, now this would be 3,600 times k. So we'll divide each side by 3,600. And then we will have approximately 0.063 is approximately equal to k if we round to 3 decimal places. So we have d is equal to 0.063 times s squared. Now, on this problem here, they give us the speed at 70. So it'd be d is equal to 0.063 times 70 squared. So when we put this in our calculator, this will end up giving us 308.7 feet. So this will be our distance. And this is the formula we use to get our distance. And this is all we need for the project.